For decades, scientists couldn't answer one of the most embarrassingly basic questions about our solar system. How fast does Saturn spin? Not how fast its moons orbit, not how fast its storms rage, just how long is a single day on Saturn? You'd think that would be simple. It wasn't, and the reason why will completely change how you see the sixth planet from the Sun. Welcome to one of the greatest detective stories in modern planetary science. Saturn is one of the most iconic objects in the entire universe, that golden, ringed giant floating serenely in the outer solar system. We've sent spacecraft to it, we've photographed it in breathtaking detail, and yet, for the better part of 60 years, we genuinely did not know how long its day was. That mystery has finally been solved, and the answer came from the most unexpected place imaginable. To understand why this was so hard, you need to know a little about how planets work. Here on Earth, measuring a day is easy. You pick a landmark on the surface, watch it rotate, and time how long it takes to come back around. Simple. But Saturn doesn't have a surface. It's an enormous ball of gas and liquid, hydrogen and helium swirling in colossal bands, with no solid ground to anchor your measurement to. Different parts of Saturn actually rotate at different speeds. Its equatorial winds scream around the planet faster than its polar regions spin. So where do you even begin? For a long time, scientists tried to cheat the problem. Every planet with a magnetic field broadcasts a kind of radio signal, a rhythmic pulse generated deep inside the planet where the magnetic field is rooted. For Jupiter, that trick worked beautifully. Jupiter's magnetic field is locked to its interior, and its radio pulses gave scientists a precise rotation rate. They tried the same thing with Saturn. When the Voyager spacecraft flew past in the early 1980s, it detected Saturn's radio emissions and measured a day of about 10 hours and 39 minutes. Problem solved, right? Not even close. Here's where it gets strange. When the Cassini spacecraft arrived at Saturn in 2004, it measured those same radio pulses again and got a completely different answer. The day had apparently gotten about 6 minutes longer. That's not how physics works. The interior of a gas giant doesn't just slow down between spacecraft visits. Something was wrong with the method. The scientific community was baffled. Some researchers started to wonder if Saturn's magnetic field was somehow decoupled from its deep interior, essentially scrambling the signal they were trying to read. For years, the true rotation rate of Saturn remained one of planetary science's most stubborn open questions. Now here is where the story takes a turn that almost sounds like science fiction. The answer wasn't hiding inside Saturn. It was written in Saturn's rings. In 2019, a team of researchers led by Christopher Mankiewicz at Caltech made a stunning discovery. Saturn's rings, those impossibly thin, impossibly beautiful sheets of ice and rock stretching out across hundreds of thousands of kilometers, are not just decoration. They are alive with vibration. Saturn's interior generates oscillations, like a giant ringing bell, and those internal vibrations ripple outward and leave their fingerprints in the structure of the rings. The rings, in other words, were acting like a seismographer, recording the heartbeat of the planet itself. By studying the subtle wave patterns in Saturn's rings, using data from the Cassini spacecraft's final years, Mankiewicz and his team were able to decode that heartbeat. They could read the oscillations like sheet music, and those oscillations finally gave them what 60 years of radio measurements couldn't: a clean, reliable measurement of Saturn's true rotation rate, tied directly to the planet's deep interior. The answer? Saturn's day is 10 hours, 33 minutes, and 38 seconds. That's it. That's the length of one complete rotation of the giant at the heart of that swirling golden world. After decades of uncertainty, it came down to waves in a ring of ice. Now pause for a moment and really absorb what just happened. We used the rings of Saturn as a scientific instrument. Those rings, the very feature that makes Saturn the most visually stunning planet in our solar system, turned out to be a precision tool for probing the planet's hidden interior. It's like if you were trying to measure someone's heartbeat from 1,000 miles away, and you did it by watching the ripples they made in a lake. The beauty of the solution is almost poetic. But the implications go even deeper than just knowing what time it is on Saturn. This technique, using ring seismology, opens a completely new window into the interiors of gas giant planets. We can't drill into Saturn. We can't send a probe to its core. But we can read the vibrations it broadcasts through its rings
And from those vibrations, we can start to piece together what's happening thousands of kilometers below the cloud tops. What is Saturn's core actually made of? How large is it? Is it a sharp boundary or a fuzzy, diffuse region where rock and gas blend into each other? These are questions we are now, for the first time, in a real position to answer. And that matters far beyond our own solar system. We've now discovered thousands of exoplanets, worlds orbiting distant stars, and many of them are gas giants. Understanding the interior structure of Saturn gives us a template, a Rosetta Stone for interpreting the nature of worlds we can never visit. Every insight we pull from those rings echoes across the galaxy. Here is the perspective shift I want to leave you with. We live in an age where we sometimes assume science has mapped everything important about our solar neighborhood. Saturn has been visible to the naked eye since before recorded history. Galileo saw its rings in 1610.
And yet, in 2019, a planet that humans have watched in the sky for thousands of years still held a secret so fundamental that we didn't know how long its day was. The cosmos is not done surprising us. The universe still has rooms we haven't opened yet, and the tools to open them are sometimes already in plain sight. A glittering band of ice circling a golden giant, patiently waiting for someone to learn how to listen. If this blew your mind even a little bit, hit that like button. It genuinely helps this channel reach more curious minds just like you. Subscribe so you never miss one of these deep dives into the universe's greatest mysteries. And drop a comment below. I want to know, what other mysteries do you think are hiding in plain sight right here in our own solar system? Because trust me, we are just getting started. Next time, we're heading somewhere even more dramatic, a place where the laws of physics themselves seem to break down. You do not want to miss it.